Hello students, Mr. Courtney here. In this video we're going to be looking at organic functional groups, and we've already talked about organic compounds as in compounds containing carbon. Now when we talk about functional groups, functional groups mean a group of atoms or bonds in a molecule that are responsible for the characteristic reactions of the molecules. We've already looked at some of these functional groups when it comes to bonds. Carbon-carbon single bond, we call these alkanes. Carbon-carbon double bonds, we call those alkenes, and carbon-carbon triple bonds, we call those alkynes. So today we're going to look at functional groups in terms of groups of atoms. Now you will be responsible for recognizing the functional groups either from their name or the structure, but you will not be expected to actually name or draw the compound. Okay, so let's get started. Alright, the first one we're going to talk about is aromatic hydrocarbons. And they have closed ring structures. That's kind of basically the functional groups with alternating double and single bonds. And these can be represented in three different ways. So we can draw the structure with the hydrogens on the outside, the closed ring structure, and showing our carbon double single bonds alternating. Or we can remove the hydrogens on the outside and we still show our carbon double bond, single bond, double bond, single bond alternating. Or we can have our closed ring structure with a ring or a circle in the middle. That shows us that the double bonds can take different positions. So in this case, the double bond could be here or here, because remember we talked about that in resonance. So that's different ways of looking at these. Here are some examples of some aromatic hydrocarbons. As we can see, they're represented in three different ways. We have one of the simple ones, toluene. Again, closed ring structure with rings with a circle in the middle. Closed ring with carbon, double bond, single bond, double bond, single bond alternating. And in this one, we have our two rings joined together. Now pay attention, double, single, double, single, double, single, double, single, double, single, double, single. So there you can see that they're going to be, they have the alternating double and single bonds. Now these, when you look at these in terms of their polarity, they're going to look the same all the way around. So when you look at these here, they're going to look the same all the way around. And we're not looking at the side groups as of now really. These side groups here, they're going to look the same. This is a bit different. Alright, but when we look at it all the way around, they're going to look the same. So that's going to make them non-polar. So these are going to be non-polar. And if they're non-polar, remember the intermolecular force will be London dispersion. Okay, our next type is alcohols. Alcohols have the hydroxyl functional group, that OH group. So you're going to see it written as RCOH. Or whether you see it like this. Let me show you because you don't need to know this. RCOH. Now that R, what does that R represent? It represents a carbon chain. Okay, and I should say a simple carbon chain, usually containing just single bonds, carbon-carbon single bonds. Okay, now in terms of naming them, we look at the number of carbons, 1, 2, 3. We name it just like we name an alkane. Then we drop the E and we end with OL. So let me show you. Instead of going with this as being propane, that's why we got rid of the E and we added OL. So alcohols are always going to end in OL. So when you look at a name of a compound, you see it ending with OL, you know that it's an alcohol. And when we look at this, we look for the OH functional group or the hydroxyl functional group here. This is what we're looking for, the hydroxyl functional group. Now here we have highly negative oxygen, which is going to pull on there, on the electrons. So oxygen will pull more on one of the set of electrons. Once that happens, we're going to create hydrogen bonds because hydrogen is bonded to oxygen. So these are going to be polar. And because we have hydrogen bonding here, all right, we have hydrogen bonding here, then our intermolecular force will be hydrogen bonding. ethers. Alright, many people refer in terms of identifying these in different ways. Some people say look for the bunny ear. I just like to say look for the oxygen sandwich. We have 2 carbon chains on either side of oxygen. The carbon chains could be the same, and if they're the same, they're symmetrical. If they're different, then they're asymmetrical. And it's easy to identify ethers by their name because the name is going to end with the word ether. Okay, so let's look at an example here. We're looking at a symmetrical ether because the 2 groups on the oxygen surrounding the oxygen are the same. We have the methyl group, so we have a dimethyl ether. And when we have where the groups are different, we have our methyl and our ethyl group. It's methyl ethyl ether or ether. Notice the word, what it ends with. It ends with ether. Okay. Now these will be non-polar. All right. So these will be non-polar, and if they're non-polar, okay. So once they're non-polar, the type of IMF will be London dispersion. London dispersion. Aldehydes. Aldehydes have R. Alright, and this here represents a carbon, so it's R, C, double bond O, H. And it's always going to be on the terminal. Sometimes we say the last R. It's on a carbon on the end, so it's never in the middle. In terms of naming it, we look for the longest continuous carbon chain. Replace the ending, take off the E and replace it with Al. So for example, 1, 2, 3, 4, 5, we expect it to be pentane. We take off the E and we add Al, pentanol. Okay? Or you might see that. So that's how we're going to identify these. Now, again, look at the functional group here. See, this will be our long chain of carbon atoms. So this is our R group. This is our C. Now we have our C double bond O H. Or sometimes you may see the functional group written like this: R C H O. So either way, you need to know these. They can look like this also. Then we have ketones. Ketones are pretty much similar to aldehydes, except that they're found on the middle. So they're not on the terminal carbon, so they're going to be in the middle. So you have a carbon chain group, another carbon chain group, then you have a carbon double bond O in the middle. So we call it a carbonyl group. R, R. So you may see it as R, C, O, R. Okay, so that's where you may see it. So let's look at, when we look at these down here, let's take this here for example. It could be written as CH3, CH2, CH2, CO, CH2, CH3. So here, let me use a different color. Here, that's one R group. Here is another R group. So R, C, O, R, just like this here. So you have to be able to identify it in several different ways. We name it just like we name it an alkane. Look for the longest carbon chain. Replace the E in the end with O-N-E. So they're always going to end with O-N-E. So this one we have hexanone, R group, R group. And as we did here, our R group and our R group. So that's how we get our ketone here. Carboxylic acids are sometimes called organic acids. The functional group R, C, double bond O, OH is represented like this also. And it's always going to be on the terminal carbon. Same naming system, replace the final E of the alkane with oic acid. So they're always going to end with oic acid. So when we look at these example, propanoic acid, this is our R group. So R, C double bond O, OH. R group, C double bond O, OH. So that's how we're going to identify these. In terms of polarity, and I think I forgot to mention polarity in the previous one. In terms of polarity, these are going to be polar, okay? Because we have that oxygen group here now. Here we have oxygen pulling on electrons here, so this is going to make them polar. And since we have oxygen bonded to hydrogen, that is going to create hydrogen bonding as our intermolecular force. So these are going to be polar, and the type of bonding will be hydrogen bonding. Alright, esters. Esters are formed when we have an alcohol reacting with an acid. So an organic acid reacts with an alcohol. So the functional group is the combination of two of them. So we have a R group, C double bond O with another O and the R group. So what you see is that the functional group can be represented like that: R, C, O, O, R. Okay, or sometimes you see that C double bond O. Once you have those two together, that tells you it's going to be an ester. So again, see our functional group here: C double bond O. Here, C double bond O with another O on it. Okay, and we name them the same as we name them based on the substituent groups. We choose the longest chain carbon, replace the E from the alkane name with O8. So they're always going to end with O8. So for example, this is, alright, we have our ethyl ethanoate and we have our methyl propanoate. Okay. Sorry, this is methyl ethanoate. Why did I say ethyl? Why did I write ethyl? Alright, because we have one carbon in, so this is methyl, and this is our ethane. Alright, ethane, so ethanoate, methyl ethanoate. Okay. Alright, so you have these practice problems to do. I'm going to go through the first set with you, and I'm going to let you do the rest on your own, and then you can come back, you can pause the video, and then come back to check your answers. So how do we go about identifying these? I'm going to show you how you can break these down in terms of looking for your functional groups. Remember, this is a continuous carbon chain, so this is R. So when we have ROH, we know this is an alcohol. Again, here, the OH group, ROH, so another alcohol. All this is a carbon chain, so this is ROH, functional group here, alcohol. Okay, now we have C. So that's R, that's an R, C double bond O R, remember R, C double bond O R's, that's ketone, so we know this is a ketone, because we're looking for this functional group in the middle. Then we have our functional group here, C double bond O O, so that is an ester. Or you can remember it as R, C, double bond, O, O, R. So that's what we have here. Okay, that's our oxygen sandwich. If it's an oxygen sandwich, you know, it's a R, O, R. So that is an ether. Good. Again, another oxygen sandwich, oxygen in the middle of two carbon chains, that's an ether. Closed ring structure, alternating double and single bonds, so that makes it a what? an aromatic hydrocarbon. R, we have a C double bond OH group on the terminal carbon. So that's R, C double bond OH, terminal carbon, so that makes it an aldehyde. C double bond O in the middle, so that's a ketone. C double bond O, so that's alright, so here we have our ester. And here we have C double bond OH, or as we say R, C double bond OH, so that's a carboxylic acid. Carboxylic acid. Okay, and here you have the solutions for the others, so you can pause the video, go through it, identify the functional groups for you, so to make it easier for you. Alright, so again, until the next time, blessings. I'm out.